students. So we were discussing the chapter about alcohol, phenols, and ethers. So discuss about what are alcohols, right? So we have seen the structure of alcohol. Then we had studied some of the alcohols, common alcohols. What are the IUPAC name? What are the common names? Right? We have studied generalization about the phenols. We have studied about the structure. Okay, we have studied about the ethers, the structure of ether. Right. Then we had started with the preparation of alcohols. So, okay. Then preparation of phenols. Right. So we have discussed this part. Then we had also studied about the physical properties of alcohols, phenols, and ethers. Right. So chemical reactions also we have seen. That is a reaction involving the cleavage of OH bond. We have seen the reaction with metals. Then we had discussed about the acidity of alcohols and phenols, right? So esterification part also we have studied. So esterification is what? When phenols and alcohols, right? Or phenols and alcohols, when they react with carboxylic acid, okay, they form ester group. Okay. So either the reaction can take place between phenol or alcohol with acid anhydride, acid chlorides, or with carboxylic acid. Okay. So depending on the reactant, the side products may be vary. Okay, the main product that is ester you'll get, and the side product will be varying depending upon the reactant which you choose. Okay. So we have studied the support esterification also. So today we are going to start with the reactions involving cleavage of carbon oxygen bond in alcohol. Okay. So first is the reaction with hydrogen halides. So when they react with hydrogen halides to form alkyl halides. Okay. So you can see ROH means what? Alcohol. So alcohol when they react with hydrogen halides, they give you RX, that is alkyl halides plus water molecule is obtained. Dehydration. Okay, so second reaction is dehydration reaction. Dehydration means what? Dehydration means loss of water molecule, right? Dehydration means loss of water molecule. So dehydration, here alcohols, okay. Alcohols, they undergo dehydration to form alkenes, okay. When you treat it with concentrated acid, so if you treat the alkenes with, alcohols with acid, okay, they get protonated and the water molecule is lost, okay. So it can take place. So this reaction takes place in the presence of concentrated acid, okay, and some catalyst, okay, and some catalyst like anhydrous zinc chloride, or aluminum. You can see the reaction. They have taken ethanol. Okay, ethanol is treated with excess of concentrated acid. Okay, acid like H2SO4, and ethanol is obtained. Okay, so plus water molecule. So loss of water molecule is called as a dehydration reaction. So what is happening in both this reaction? You can see that there is a cleavage of CO bond. That is, CO bond is broken and a new bond is formed. Okay, right here also. So this was a CO bond. So this is a CO bond, right? So if I take alcohol like CH3, CH2OH plus HCl, okay, gives you what? It gives you CH3, CH2, Cl plus H2O, right? So what is happening here? This CO bond, right? This CO bond breaks. So this CO bond breaks to form your CCl bond, right? That is CX bond is formed here. Here, what is happening? See, the CO bond breaks to give you CH bond, right? So, there is a breaking of the old bond, that is CO bond, and what is formed here is new bond is formed. So, we'll see the mechanism. So, very important from board point of view. So mechanism of acid catalyst dehydration of ethanol. So you can see ethanol. So what they have done, ethanol is taken, right? Ethanol is taken. So the lone pair of electrons from the oxygen attack, okay, they get attack to this proton. So we are reacting it in the presence of some acid. Okay. So what happens? So this alcohol gets protonated. So when this lone pairs of electrons from oxygen. Okay, so lone pairs of electrons from this oxygen, they attack this proton. Okay, this is a fast reaction and protonation takes place. You can see here. Okay, oxygen can have only two hands. Okay, so here it is having three hands. So it is what? It is undergoing protonated. Protonation is taking place. Then second step is what? Formation of carbocation. So what is happening? There is this bond is broken. That is between CO bond is broken. CO bond breaks and this water molecules will leave. So this is a slow process. So the carbocation is formed on this okay, leaving behind the electron deficient carbon and water molecule is uh, obtained. Okay. Then the third step is elimination of protons. So there is an internal rearrangement reaction taking place so that the carbocation which is formed to be stabilized and what is happening, ethane is formed. So this is the mechanism. So it is a mechanism of acid catalyst dehydration of ethanol. Very important reaction from board point of view. Okay. So next we'll see some of the important reactions. So this we have already studied in your classes, okay, in your colleges. So we'll just have a quick glance on these reactions. Okay. Here, the first name reaction is Rimmer-Timmer reaction. Okay, Rimmer-Timmer reaction is what? It is a chemical reaction which is used for orthoformylation of phenols. Okay, so here we are doing this reaction on phenol. Okay, this is a very important reaction on phenol. We are converting the phenol to salicylaldehyde. Okay, to salicylaldehyde. So we are converting it to a salicylaldehyde. Okay. So we are converting this phenol to what? We are converting this phenol to salicylaldehyde. Okay. So what it is a chemical reaction which is used for the orthoformylation of phenols. Okay. It is used where? It is used for the orthoformylation of phenols. So this is a simplest example wherein we are converting the phenol to salicylaldehyde. Okay. Now, so you can see this reaction phenol. We are treating it with chloroform. Okay, CHCl3 is what? It is chloroform. So we are treating the phenol with chloroform and what? And alcohol. That is sorry, base like strong base like aqueous NaOH. So what is happening? This is an intermediate product. Okay, it so your the um, CHCl2. Okay, this is an intermediate product which is obtained. So, okay, so this will further will be treated again with the base like NaOH. Okay, and what is formed? This CHCl2 is converted to CHO. That is a aldehyde group. Okay, aldehyde group. Now, what we have to do is we have to add here proton. So, if you do protonation, what will happen? This O minus Na plus. Okay, that is a phenoxide ion. So this will be converted to OH, that is salicylaldehyde. So this is the important reaction wherein we are converting our phenol to salicylaldehyde. Okay, so we are doing formylation. Okay, we are introducing a formyl group on the uh, phenol, right? So we are doing at ortho position. It is undergoing formylation on phenol. So it is called as orthoformylation. Okay, it is called as orthoformylation. Next important reaction is the Kolbe's reaction. So Kolbe's reaction is also very important reaction wherein we are converting our phenol. Okay, so phenol, what we have done, phenol is treated with NaOH. So what is happening? This your OH group, okay, is converted into phenoxide group. So that is sodium phenoxide. sodium phenoxide. So it is forming what? Sodium phenoxide. It is O minus Na plus. Okay. So this H plus is replaced by Na plus. So it is forming a sodium phenoxide. So this is also an intermediate product. Okay. This further your phenoxide, it is sodium phenoxide. When you heat it with carbon dioxide, okay, and okay, carbon dioxide, and further when you do protonation, it will form salicylic acid. So because of carbon dioxide, it gets at ortho position. Okay, at ortho position, carboxylic group is introduced. Carboxylic acid group is introduced. Okay, so the product form is 2-hydroxybenzoic acid. What is the product name? The product name is 2-hydroxybenzoic acid. Okay, it is a salicylic acid. Okay, it is a salicylic acid. The name is salicylic acid. So when you convert phenol to aldehyde, it is salicylaldehyde. And it is a Rimer-Timmer reaction. When you convert your phenol to salicylic acid, okay, that is to a carboxylic group, then it is called as that is when you're converting it to a acid, it is called as salicylic acid. Okay, the reaction is cold-base reaction. So one more very important reaction. Next is Friedel-Crafts reaction. So Friedel-Crafts reaction, it is a very important reaction where it undergoes a coupling reaction, okay, which involves electrophilic aromatic substitution that is used for attachment of substituents to aromatic ring. Okay, so this is the electrophilic substitution reaction. Okay, so you can see methoxybenzene, or it is also called as what? Methoxybenzene, or it is called as anisole, right? It is called as anisole. So when it is treated with methyl chloride. Okay, methyl chloride in the presence of anhydrous AlCl3. What is obtained? Just see. Okay, 2-methoxytoluene is obtained. 2-methoxytoluene is obtained. Okay. Mm, and so the two products are obtained. One is a ortho product and one is a para product. Always the para product is very uh, major product. Okay, because there is no steric hindrance. Okay, here you can see the bulkier groups are present close to each other. So this is a minor product. So this is undergoing a alkylation. So this we are doing Friedel-Crafts alkylation reaction, and this is acylation reaction. Okay, this is acylation. So again, methoxybenzene, when you are treating it with okay, acylation product, that is okay, it is undergoing acylation in the presence of anhydrous ClCl3. It is forming 2-methoxyacetophenol, okay, and 4-methoxyacetophenol. So wherein the para product is the major product. So another Friedel-Crafts reaction, very important reaction. Next, we are seeing some of the name reactions of ethers. Okay. Next, we are going to see some of the name reaction of ethers. So, very important, Williamson synthesis. Okay. Williamson synthesis, very important reaction wherein you are treating your alkyl halide, okay, with sodium alkoxide. So, with sodium alkoxide, you are treating your alkyl halide, okay, and it undergoes a okay. So how the reaction takes place? ROR plus NaX. Okay, so this is the reaction. So when alkyl halide is treated with sodium alkoxide or sodium phenoxide, it is undergoing a Williamson synthesis. Okay, it is undergoing a Williamson synthesis. So from this type of what is that synthesis, you can produce both simple ethers also, and you can produce the mixed ether also. Okay, both the type of ethers can be produced. So depending upon structure and cleavage of unsymmetrical ethers by halogen acids may occur either by SN1 or SN2 mechanism. So by this Williamson ether synthesis, you can produce a type of ethers. Okay, you can produce either a simple ether or you can produce a mixed ether. So depending upon the structure and where the cleavage is taking place of unsymmetric ether, so it may vary in the mechanism, either SN1 or SN2. Okay. Next is hydration of alkene. So another important this, that is hydration of alkene. So this is a alkene. Okay, this is a alkene. So alkene, when you treat it with water, so hydration means what? Addition of water. Okay, hydration is addition of water, and dehydration means removal of water. Okay, dehydration means what? Removal of water. Okay, so first we are seeing the addition of water. So when you are adding water to the alkene in the presence of H plus, okay, what is happening? So hydrogen, so it is a symmetrical alkene. So on the either side of the double bond, one carbon, hydrogen is added because water, okay, it splits into H plus plus OH minus. So H plus ion will get attached to one of the carbon and OH will attach to the another carbon. Okay, so like this the reaction takes place. Now suppose when you have a unsymmetrical alkene. Now this was in case of symmetrical alkene. Now suppose when you have a unsymmetrical alkene, you have a unsymmetrical alkene. So that time how this addition of water takes place, right? So it will undergo a Markovnikov rule, wherein the negative part will be added to the carbon which has less number of hydrogen, and hydrogen will be added, the hydrogen will be added to the carbon with the more number of hydrogen added to the carbon which is having more number of hydrogen atoms. So like this. So here this is less, so OH will be attached here and here the CH3. Okay. So like this is the reaction taking place. I hope this is clear. Next is dehydration. I said it is removal of water molecule. Okay, removal of water molecule. So how you can remove the water molecule? By if you when you do when you add the acid, okay, from alcohol, that is CH3 CH2 OH. Okay, so when you treat it with concentrated acid, so what happens? Protonation takes place. Okay, protonation takes place and water molecule is removed. Okay, so here you can see protonation. So it can occur by three forms. So CH3 CH2 at one. Okay, so when we are treating it, when it is undergoing a reaction at 373 Kelvin and 100 degrees Celsius, it is forming CH3, CH2, HSO4. Okay, HSO4. The negative part, that is OH minus, is replaced by HSO4. Then when you treat it with your alcohol in the presence of concentrated acid at 413 Kelvin, it forms a ether. It forms what? It forms a ether, that is CH3 CH2O and CH2 CH3. Okay, a simple symmetrical alkene ether is formed. The third reaction, when you react the alcohol with the concentrated acid at 433 to 442 44 Kelvin, okay, it forms a alkene. So based upon the temperature condition also, the reaction conditions will vary. Okay, here you can see how the this, if you take two molecules, okay, if you take two molecules of your alcohol, okay, if you treat two molecules of alcohol, you treat it with acid, okay, at 413 Kelvin, what is obtained? You obtained the ether. Okay, you obtained the ether, that is simple symmetrical ether is obtained. Okay, so this was the dehydration reaction wherein there is removal of water molecule. Okay, I hope this is clear. So by this we have completed the synopsis based on alcohol, phenols and ethers. Okay, so in the next class we'll be studying uh about the MCQs. Okay, so in the next class we'll start with the MCQs. So I hope today's session is clear. Okay, so we'll meet in the next class. Thank you.